Let's start with the very simple use case for using Metaflow tags, and why would you do it? Well, here's a very simple, although typical Metaflow workflow that trains a decision tree model. What the flow does is really not that important, but just to give you an idea, we load this CSV file that has many features. Like one of the features is this column called attrition. It's a binary label, like whether the employee stayed at the workplace or not, and like we want to predict that. So we load the file here, like we do some like a very basic feature engineering here, like encoding the categorical columns and so forth. Again, the details really don't matter like for this example, but I just want to demonstrate in the context of a real life use case. And then like we do a train and test split here, like we reserve 70% for training and so forth. And then in the train step here, we train the actual decision tree classifier using these parameters that you can see here. Once we have the model, we can evaluate the model performance using standard scikit-learn tools, like we look at the accuracy score, like we print it out and store it as a Metaflow artifact. And finally, in the last step, we create a visualization of the decision tree. I mean, just for convenience, so we can eyeball what's going on. And now, as usual with Metaflow, we can simply run the code on the command line by doing Python simple tree run. And now, since we have that visualization of the decision tree, like what we can do is that we can do simply with card, which enables the Metaflow card feature, so we can actually get that kind of a report that shows what's going on. And now, one thing that I should have mentioned is that like we also use the conda decorator to include the library dependencies here. So scikit-learn, pandas, graph, these are the tools that we are using here in this case. And now we have the model trained. The accuracy is 0.78, as you can see here. And now we are creating the visualization. So that's looking pretty good. So now what we can do is that we can switch to the Metaflow UI. And here in the Metaflow UI, now we can see that, okay, we have this execution of simple tree. Like if we look back here in the code, like we can see that this is the kind of the run ID that we had, and the run ID is exactly the same what we have here. So now when we click this, like we can go and like we can look at the end step. And now we have the card here, and the card contains a bunch of information about the execution that we just did. I mean, it has the same accuracy number here. But the thing that we are really looking for is this visualization of the decision tree. And now, as you can see, this decision tree is actually quite complex. It's probably overly complex for the small data set that we have, so maybe the model is overfitting. So now what we can do in this case, which is of course very typical in data science, like especially as we are prototyping a new project, we can maybe go back to the modeling parameters here, and like maybe we change some of these hyperparameters. Maybe for instance, like we can limit the maximum depth of the model. So we limit that to 4, and now we run the code again. So let's do the run with card again and see what happens. So now the code is running, and actually like right away we can go back to the UI, and in the UI like we should be seeing the new run here. So you can actually see that the kind of now the evaluation is going on, and after the evaluation is done, in a minute we should see the end step here. And now when we click the end step, like we can take a look at the card, the new one. And now the model looks much more balanced and much nicer. So we have a reason to believe that this model probably performs much better. Actually, like if you look at the accuracy score here, it's 0.84. So that's much better than what it used to be. Now, like if we go back to the home screen, you can see that like we had the original version of the run, like with the bad results, with the bad model, and then we have the new one that performed much better. And now, maybe if you come back to these results maybe a week later, or like you want to share these results with a colleague of yours, of course, like how would they know like which one of these runs correspond to the run that actually worked? And that question is exactly the motivation for the tagging feature, because like now what we can do using the new tagging feature that we just released is that like we can go back to the command line here, and we can do tag add, and then we give the run ID of the run that like produced the desired results, and then like we can come up with any kind of any name for the tag. Let's say in this case it's a good model, so let's say that it's a good model. And now in this case we assigned a tag, a user-defined tag, like for this run, for this execution. There were a bunch of tags that Metaflow assigns automatically, but now we also have the new one. And now the cool thing is that like if we go back to the UI here, like we can see that we have now this execution tagged as good model. And now what we can do is that, for instance, if we filter only by the tags good model, we can share this exact view. You could copy paste this URL and like your colleague would be seeing only the kind of the results that you want them to see. So for instance, now when they click this, they can like see the model and they can like only see the model that was performing well. And of course, like this is exactly the type of tagging that that you see in many other tools as well. So nothing too special here, but I mean, this is definitely a convenient feature. In the following segments, we will go into a bit more advanced use cases of tagging. So keep on watching.